Okay, this is going to be the functional video showing it actually working. First thing I'm going to do is turn the unit on. Unfortunately, I can see those numbers real well, but I've already checked the camera, and the camera only sees a white, or actually a green tint display. I don't know why I can't see the numbers like I can, but c'est la vie. So I'm going to ask you to take my word, or I'm going to tell you the frequency that I've dialed in and that's displayed, and you're just going to have to believe it. So the first thing I do is, we've got this thing running right now, not driving anything, is I'm going to connect up the probe, and there was some juice there, and so I've used one of the outlet receptacles just to monitor the probe. The signal, it's on, and no, I have nothing plugged in, so it's just free running. The scope is just seeing a lot of noise right now. So plug in a light. There we go. And see where we're at here. There we go. So the unit came up at, it looks like, unit came up as 10 hertz. So that is a 10 hertz pulse. You can see the light flashing at 10 hertz. You can see a beautiful square wave. And what I'm going to try to show you here is the frequency range up to 20 kilohertz, and you get to see what it looks like. It's not perfect at 20 kilohertz, but it's pretty good. Good enough to do the things that I want to do, and a lot of other people want to do, and that is to pulsate infrared sources, pulsate heating units, possibly plasma tubes, and vortex coils, which I'll demonstrate later in another video. So right now it's set for 10 hertz, and you can see that it's a nice square wave. This is 1000 hertz, and a little more stable, and you can see that's a nice square wave, beautiful trailing and leading edges, just a beautiful square wave at 1000 hertz. I'm going to dial it up to arbitrarily 10,000 hertz, and now you can see that I'm getting a little rounding on the square wave corners, just a tiny here and a little at the top, and that square wave will shape up a little bit better or less depending upon how much current I'm drawing. When I draw a heavier source, and I think I'm just going to show you rather than talk. Right now I'm drawing 7 watts with this little lamp. Scope will get out of sync for a second. Actually, scope won't show you anything for a few seconds. And now I have 100. And you can see a little bit more rounding, but a much steeper trailing edge. Maybe not too much more rounding on the leading edge. The trailing edge is very steep, falls off rather dramatically, and that's because the MOSFET responds better when it's turned off than when it's turned on. It finds no problem in saying, okay, I'm all finished, but when it turns on, it says, oh man, I got to get going, and it has a little harder time starting up. So that's at 10 kilohertz. I hope that light's not too bright for the video. As a matter of fact, just in case it is, I'm going to go back to the little blinker, and I know that's not too bright. And I'm going to dial up to, I'm going to double that. I'm going to jump right up to 20 kilohertz. And now you can see a significant difference in the square wave. A couple of things start happening when you get up around 20 kilohertz. First of all, it's not perfectly symmetrical. Perfectly symmetrical would be more like, I'm changing the duty cycle, would be more like that. That's not perfect, but that would get you a closer to up on an equal amount of time that it's off. I have the capability of easily going up to higher frequencies. In fact, I will do that. But higher frequencies than 20 kilohertz is outside the interest that I have with this box, because I geared this box to be able to handle frequencies from a fraction of a hertz all the way up to 20 kilohertz to stay within the range of the Rife frequency list and the Holden-Clark frequency list. But we will go to right now 30 kilohertz, and you can see it's not a perfect square wave. Still has a square wave type shape to it. 40 kilohertz. Little ringing on the trailing edge here. I can square that out a little bit better, make it a little more symmetrical. And this again is strictly the function of the MOSFET's capability to turn on and off. You can see some slope now to the rising edge, and you get a little rounding. It's not a flat top anymore. And we're at 40 kilohertz. I can get up to 50 kilohertz. And not that one, but if I press that button, now we're at 50, and we still have a reasonably good square wave. I advocate that this box will go up to 50 kilohertz. It's well within spec there. I'm just dialing it up. I'm up to, now you can see I'm up to 90 kilohertz, and now I no longer have a square wave, and I have to play with the duty cycle to try to even get it close to looking like a square wave, which I can. I'm getting a little bit closer. So in actuality, I probably could get 100 kilohertz out of here, turning on and off a device 100,000 times a second at 160 volts. That's quite significant. You could do a lot of serious work with a poor man's frequency converter like this, or what I call the pulsar. All right, so let's get reasonable here, and let's reset it, and now we're back to 10. There we go, and dial down, do a little sync job here, and we're at 10 kilohertz. All right, this is only a small portion of the capability of the frequency generator that's used in this frequency converter box, or the pulsar. Frequency converter or pulsar I use interchangeably. They are the same thing. As I talk, that's what I mean, they're the same thing. All right, so let's look at the MP3 player. So we're going to turn this light off for a moment. And I have the MP3 player already turned on, and it's in an area right now of about 2 minutes. This is a 10,000 hertz signal. Hopefully it is a 10,000 hertz signal. Okay, is that a 10,000 hertz signal? I'm just validating it, so I give you the straight skinny. Yeah, it looks like a 10,000 hertz signal. I've got to sync it in. So that's coming from the MP3 player, and the MP3 player is telling this thing to sing at 10,000 hertz. Boy, that's just too clean for me. I don't quite. I just don't think that that is 10,000 hertz. What I'm going to do is I'm going to reset that. No, it's not. Okay, I don't have to. That now that's 3,000 hertz. And if I look at the scaling here, 2 megs, 2, 4, 6. Yeah, that's roughly 3 kilohertz. Pretty decent signal. It started out at 10. We just didn't get to see it. I'm not going to rewind it. It takes takes too much effort to go back and forth on this thing. Okay. So what this will allow me to do is to create a sequence of frequencies. If I want to create a pattern of 400 hertz, 1,000 hertz, 10,000 hertz, 3,000 hertz, anything in between, I can create a sequence and I can run the file for as long as I want, or as long as the batteries last in your MP3 player. I would like to find an MP3 player, opening up to suggestions, that I can be running off of AC while I'm playing it, or not necessarily AC, but a little DC source. All the cheap ones, they run off of batteries, or they run off of your computer, but they can't do this. They can't be powered on and play at the same time through your computer. Leastwise, a couple of the MP3 players. I have a Sony Walkman, for example. When I connect it to my computer, it won't play. It allows me to upload and download files. That's all it'll allow me to do. This guy is very similar. There's a few differences, but regardless. I'm looking for a nice $20 for a 2 gig. This is a 2 gig MP3 player. I'm looking for a nice MP3 player that I can use to generate signal and also to run off of 5 or 12 volts, so I can provide it in this box simultaneously, as if it was plugged into a computer. A little bit of jitter. You might be able to see that. Insignificant for the things that I want to do. All right, so now let's start demonstrating some practical aspects of this. Right now, I've already plugged in the light bulb here. I'm going to unscrew this, and I'm going to put the far infrared in here. And if I take this off, it just switched to another frequency, whatever it was, whatever was in the sequence of, in the chain of events here. It looks like it's about, well, that's much higher. That's probably close to 10,000. All right. I'm going to unplug this and plug in the FIR device, FIR standing for far infrared. Let's see if I can sync it a little bit better. And this now is, I can feel it starting to warm up. This is getting warm, and this is also pulsing the far infrared rays out there. These devices are used to in saunas, in aquariums. The far infrared has a capacity to heat without any light that's visible to both the animals and to us. And they say that far infrared has some remarkable health properties. Hence, I'm showing you a far infrared emitter. Far infrared emitter. Running at 150 watts. Running from an MP3 file versus this. Now I can just unplug the MP3 file and dial some more frequency here. Let's dial. And now it's running at a nice 1,000 hertz. Yep. Actually, it's 1,010 hertz. Pulsing out and just running. Another device, I'm going to just leave that, that's gotten hot, so I don't want to touch it. Another device that I run, and which started this whole box, was the heat blanket. I took a heat blanket and I took the controller off and modified, and get the other end here, and modified the plug to plug in to a wall outlet. What it does, it turns the heat blanket on full power, when you do that. You have no control if you remove the controller from the heat blanket. These heat blankets, this particular one was bought at Walmart. Costs about $40. It's a twin size. It's got 2 coils in it, a left and right, hence the 3 wires, left side, right side, and common ground in between. So if I plug this in and sync on the signal, so now this is pulsing at 1,000 hertz. What I normally did was I would run it down at Schulman's resonance, or what I normally do is run it at Schulman's resonance. I made a box called the Schulman box. It's all it was. It's an oscillator that oscillated at 7.83 hertz. And then I decided that I needed to have more capability, and hence the pulsar evolved into what it is today. So now I can run complex frequencies and so forth, get nice and warm and cozy, and those complex frequencies that I pulse the blanket at do whatever they do. No claims. All right, so here are 4 examples. The little light bulb, the big light bulb, a heat blanket, and a far infrared emitter, all being driven with a pulsar. The next video after this one will be on this monstrosity here, the vortex coil. And what I do with the vortex coil is I create some huge or very powerful magnetic flux, magnetic waves, and they also have some interesting benefits. This also is used in an energy, a couple of energy projects, lighting LED lights and running them at certain frequencies. You seem to make them a lot more efficient than running them at 60 hertz sources, or even a converted, or just DC, various DCs. So there's a lot of things you can do with this device here, and the pulsar will be, I'll call it my main tool. So that's it for this second video. Hope you enjoyed it, and I look forward to making more and giving you more insight on what we can do with this box. Have a nice day now, and goodbye.